So imagine you're watching a live Super Bowl broadcast, right? The crowd is roaring, the announcers are crystal clear, and the picture is just flawless 4K.
Yeah, pristine.
Exactly. But what you don't see is this almost $2,000 pocket-sized device aggressively ripping that audio and video apart and then like stitching it back together in real time.
Right.
So welcome to today's deep dive. We are looking at the AJA 12G-AMA-R-ST mini converter to really understand the heavy-duty engineering that makes those pristine broadcasts possible.
And it is wild to think about the sheer volume of data moving through that tiny box. I mean, we're talking about a 12G SDI pipeline here, which is basically a massive, uncompressed digital video highway.
Wow.
Yeah, and it's managing all of it without dropping a single frame.
Okay, let's unpack this. Think of that 4K signal like a high-speed train. The video is the locomotive and the audio tracks are the passenger cars.
Oh, I like that.
Right. So this device acts like a high-tech rail yard. It allows you to uncouple specific audio cars, swap them out, and reconnect them without ever slowing the train down.
Exactly. And that mechanism is actually called disembedding and embedding because, well, digital video signals actually weave the audio data into the tiny digital blank spaces of the video feed itself.
Wait, into the blank spaces?
Yeah. So this converter has to digitally unweave them in real time. It strips the audio out so you can route it to a separate mixing board, which is the disembedding part.
Right.
And it constantly adapts, automatically detecting whatever video standard is coming in, all the way up to 4K.
But wait, if it's unweaving the audio, does it have to pull everything at once, or can you be, surgical about it?
What do you mean?
Like if I'm broadcasting a global feed and I only want to swap out a single French dub track, do I have to touch the original stadium noise or the 4K picture?
Oh, no, you can be entirely surgical. It features user-selectable channel pairing.
Okay.
So you can let the original input audio pass through completely untouched or embed entirely new analog audio on specific channel pairs.
Wow, that's incredibly precise.
Yeah, I mean, in a live sports broadcast, you need the ambient crowd noise to stay pristine, but you have to perfectly inject the local announcers over the top. This does that manipulation without degrading a single pixel of the video feed.
And to physically pull that off, the gear itself has to connect to standard broadcast equipment. Like it ships with an XLR breakout cable, providing 4 channels in and 4 out.
Right, which is crucial because professional soundboards use those thick 3-pin XLR cables to keep the audio perfectly grounded and, free of static.
But routing that separated audio locally is only half the battle, isn't it?
Yeah, exactly, because if you're running this in a massive stadium, a standard copper cable is going to lose that giant 4K signal after just a few hundred feet.
But bandwidth is simply too high.
Way too high. That's why this specific unit has a built-in ST fiber receiver. Fiber optics use light to transmit data, which just solves the distance problem entirely.
Oh, wow.
You can shoot that massive 4K file miles across a stadium complex with zero signal degradation.
You know what's funny about this bleeding-edge fiber optic gear, though? It still has physical, old-school DIP switches on the side.
Oh, yeah.
You can literally configure this massive data pipeline by flipping tiny physical switches with a pen. Or, well, if you prefer, you can plug it into a modern USB port and use their AJA mini config software on a computer.
It bridges a vital gap, honestly. In a high-stress live event, an old-school broadcast engineer might just need to flick a switch immediately without booting up a laptop.
That makes total sense. You don't want to be waiting for a software update during a live broadcast.
Exactly. It's built for environments where failure just isn't an option. I mean, the fact that they slap a 5-year warranty on this tells you it's meant to be tossed in a road case, shipped across the country, and expected to flawlessly handle the Super Bowl without going down.
It completely changes how you look at television. The next time you sit down to watch a perfectly synced, crystal clear 4K broadcast, take a second to appreciate the brutal, real-time data unweaving happening in tiny metal boxes behind the scenes.
It really is a massive hidden infrastructure just to keep the audio and video married together.
Which leaves a fascinating question to chew on.
Yeah.
If a highly sophisticated $1,800 piece of hardware is required just to act as a rail yard and extend 4K data via fiber optics today, well, what kind of extreme behind-the-scenes infrastructure is going to be required when the world inevitably shifts to 8K?